Have you ever considered that AI isn't actually answering your questions, but is simply writing the next word?
Right, it's just guessing.
Yeah. Like, while humans are sitting around pondering the meaning of life, a model like GPT is literally just pondering the next token.
Exactly. It's just looking at the math.
So how did a glorified autocomplete trick the entire world into thinking it's alive? Welcome to today's deep dive. I'm your host, your curious AI guide, asking all the big questions today.
And I'm here as the AI expert and, well, storyteller, I guess, to help unpack the actual science behind all this magic.
Because it really does feel like magic.
Yeah.
But today, our mission is to demystify what GPT actually is. You know, how it shifted from this basic statistical tool into an absolute inspiration machine.
Yeah, and what that actually means for you, the listener, especially if you're trying to understand the field or maybe pivot your career into AI.
Right, because if you're looking at AI right now, you are probably just drowning in acronyms.
Oh, the buzzwords are everywhere.
They really are. So let's clear the fog. Let's start with GPT. We hear those three letters constantly. Generative Pre-trained Transformer. Can we just tear that apart mechanically? What is the G?
Sure, so the first piece, generative. It's actually a massive, massive departure from how traditional software works.
Because normally we just search for things, right?
Exactly. Old search engines, databases, they are retrieval systems. You ask a question, and they essentially go into a filing cabinet, pull out a pre-written file, and hand it to you.
Like looking up a book in a library.
Right, but a generative model doesn't have a filing cabinet of answers. It creates the response from scratch, token by token, right there in front of you.
Okay, so it generates it live.
Yeah.
And the P, pre-trained. I assume that's how it learned to actually do that generation.
Yes, but it's not like going to school and memorizing facts for a test.
Wait, it's not?
No, it's more like reading the entire internet just to absorb the fundamental rules of human language. It absorbs the patterns.
Oh, so they're not memorizing Wikipedia articles word for word.
Not at all. During pre-training, the model is fed this massive sea of human text. Books, articles, code, forum arguments. It reads everything.
Just soaking it all in.
Exactly. But it isn't saving those documents. It is mapping out the mathematical relationships between words. So it figures out that, the word apple often appears near the word tree or pie.
But rarely near, like Sparkplug.
Right, exactly. And by the time you interact with it on your computer, that pre-training phase is completely finished. It has already built its intuition.
That is so wild. It reminds me of that old saying from the sources. Like, if you read 300 Tang poems, you can chant them, even if you can't write them.
Oh, that's a perfect analogy.
Right, because you internalize the rhythm so deeply that the output just becomes second nature. So for GPT, the rule is basically read the whole internet and you instantly know how to reply.
You just know the flow.
But wait, if it just knows how to reply, there has to be some sort of actual mechanical process triggering those words, right? Like, how does it actually generate those replies?
Okay, so the central mechanism here is called next token prediction. And this is where we really have to shift our entire perspective on how language works.
Okay, shifting perspective. I'm ready.
GPT's world is incredibly narrow, right?
Mm-hmm.
It doesn't formulate some grand thesis statement before it starts typing out an essay. It only sees tokens.
Tokens, like words.
Sort of, but a token isn't always a full word. Sometimes it's a prefix, a suffix, or just a syllable. Like the word hamburger might be broken into a ham token and a burger token.
Okay, so it's working with these little chunks of language.
Exactly. And the machine's sole solitary job is to look at the preceding text and guess the very next token. It's like playing a massive game of solitaire. Or autocomplete.
Autocomplete. Okay, let's visualize that for the listener. Say I go into the prompt box and I type, the weather's good, I want to go. What is happening in the mathematical brain of the machine in that exact millisecond?
So the system takes your sequence and runs it through billions of internal mathematical dials. We call these parameters.
Parameters, right? I've heard that buzzword.
Yeah, and these are basically the weights and biases it learned during that pre-training phase. So it calculates a probability distribution for every possible token in its entire vocabulary.
Wait, every single token. So it's assigning a percentage score to thousands of potential next words simultaneously.
All at once. It computes that based on the context of weather is good. The word outside might have, say, a 45% probability.
Makes sense.
And to the park might be 30%. To sleep might drop to 1%. And Sparkplug is down at like 0.0001%. Poor Sparkplug. So it just picks the winner.
Essentially, yes. It selects a highly probable token, adds it to the sequence, and this is the crucial part, it repeats the entire process for the next token.
Oh, I see.
But now the context includes that new word it just generated.
Okay, wait, I have to stop you there because this is the fundamental sticking point for me.
Okay, what is it? If this is just guessing the next word based on percentage points, I mean, if it's literally just a trillion parameter game of autocomplete using the web as a reference, how on earth is it answering deep questions?
Right. People always ask that.
Like, how is it passing the bar exam? Or writing highly complex Python code? My phone's autocomplete turns into absolute gibberish after like 5 words.
It definitely can't pass a law exam.
No, it definitely can't. And that's because the difference between your phone's autocomplete and GPT is the T, the transformer architecture.
Ah, generative pre-trained transformer. Okay, so what does the transformer do?
More specifically, GPT relies on a variation called a decoder-only transformer. See, your phone just looks at the last 2 or 3 words you typed. It has 0 long-term memory.
It forgets what I was talking about immediately.
Exactly.
Yeah.
But the transformer solved that memory problem using an architecture mechanism called self-attention.
Self-attention, that sounds almost, I don't know, psychological. But we are talking about cold, hard math. How does an equation pay attention? Well, think of self-attention as a way of drawing invisible lines of gravity between tokens.
Lines of gravity.
Yeah. As the model reads your prompt and as it generates its response, it maps every single token into a massive multidimensional space. It basically evaluates how much every word relates to every other word in the entire document.
So wait, if I'm having a really long back and forth conversation, and in the very first paragraph I mention a rusty blue car,
Okay.
and then like 3 paragraphs later I ask, can you fix it?
Yeah.
Older AI models would look at the word it and
Oh.
just have no idea what it meant, right?
Right. They just guess the next word based only on the phrase, can you fix it? They would lose the thread entirely.
But this new system doesn't.
No, because self-attention calculates a heavy mathematical connection, that gravitational pull between the token it in paragraph 4 and the tokens rusty blue and car all the way back in paragraph 1.
Oh, wow. So when it calculates the probabilities for the next word after can you fix it, the parameters heavily favor words related to auto mechanics.
Exactly. Rather than, plumbing or software debugging, the entire history of the conversation dynamically shifts the probability of the very next syllable.
That is brilliant. But there's a constraint here, right? Because earlier you specifically called it a decoder-only transformer. What does that actually mean for the generation process?
It means it operates under a strict rule called masked attention. When GPT is generating a new token, it can only look left.
Look left? You mean back at what's already there?
Right. It can only look at the words you provided in the prompt and the words it has already generated itself. It is mathematically masked, basically blinded from looking to the right.
Because the right doesn't exist yet. It hasn't generated the end of the sentence.
Precisely. It cannot peek ahead into the future to see how its own sentence will conclude, just to adjust its current word choice.
Okay, if you're listening, imagine this. It's like being forced to write a 5-page essay, word by word, straight through, in permanent pen.
Yes, no erasing.
You are never allowed to look at a concluding paragraph, you can't sketch an outline, and you can't go back and edit a sentence you already wrote. You just walk one step at a time.
But because of self-attention, each footprint is perfectly guided by the context of every footprint you left behind.
Wow. That is such a wild way to think about writing.
And because it has hundreds of billions of parameters, those tiny mathematical rules it learned during pre-training, its intuition for what footprint should logically come next is astonishingly accurate.
So that scale of parameters is really what separates it from a simple autocomplete.
Exactly. It has enough dials to capture the deep nuance of human logic, coding syntax, legal reasoning, you name it.
Well, let's dive deeper into that intuition for a second, because the sheer accuracy of these probability guesses, it creates a really bizarre psychological effect on us.
Oh, absolutely.
Like, people talk to these interfaces like they're therapists. They pour their hearts out to a chatbot, and the chatbot replies with something so seemingly empathetic and nuanced that the user walks away feeling genuinely understood.
And that's where we really have to separate the output from the mechanism.
What do you mean?
The model does not possess understanding. It does not feel empathy at all.
Not even a little bit.
0. What it does is execute tasks flawlessly. It maps statistical language patterns, it learns context relationships through self-attention, and it outputs the highest probability sequence.
So when I say I am having a terrible day, everything went wrong, and it replies, I'm so sorry you're going through that. Do you want to talk about it?
Yeah.
It isn't feeling bad for me.
No. It simply calculates that across the billions of human interactions it read during pre-training, the phrase, "I'm having a terrible day," is statistically followed by empathetic language.
It creates the illusion of understanding just by holding up a mathematical mirror to our own linguistic expectations.
That's beautifully put. It guesses exactly what you statistically expect a compassionate entity to say.
It's like giving a fresh spin on that old proverb, right? Instead of seeing a person speaking human, seeing a ghost speaking ghost. GPT basically operates by looking at the context and speaking the most probable words.
Yeah.
We see a therapist, the model speaks therapist. It is purely context-driven probability.
The feeling that the AI gets you is really just a byproduct of its massive, pre-trained vocabulary mapping.
Okay, but let's zoom out to the broader impact here. If this is just a guessing machine playing an unimaginably complex game of statistics, why is the global economy bending over backward to adopt it?
Because of the scale.
Right. The 2026 Generative AI market reports show over 70% of global enterprises are embedding this into their business functions. We aren't just experimenting anymore, we are in the massive scale phase.
We really are.
So why the global hype for a glorified token predictor?
Well, the shift is happening because we've moved from calculation to creation. Historically, computers were strictly logical tools bounded by a rigid rule.
You input a formula, the CPU executes it, and you get a single deterministic answer.
Right, it was a calculator. But human knowledge and business operations aren't always rigid math equations. They're messy. They're language-based.
And because language encompasses almost all human knowledge, I mean, law, medicine, coding, marketing, a machine that can generate language can effectively generate knowledge work.
Exactly. We are seeing these probability engines become what the industry now calls inspiration machines.
Inspiration machines, I love that.
And the tokens aren't just text anymore. With multimodal advancements like Gemini 2.0 or GPT-4o, the next token could be a pixel in an image, a frame in a video, or even a frequency in a sound wave.
Wait, so it's applying that exact same look left, guess the next piece logic to reality itself?
Literally, yes.
Yeah.
We are seeing these models process live video streams from factory floors right now.
No way. Really?
Yeah. The AI looks at the sequence of video frames, those are the previous tokens, and if it predicts that the next logical frame involves a worker getting injured by a machine based on their current trajectory,
Then we can see it coming.
it flags a safety violation in real time. Or, another example, it analyzes live surgical video and generates a standardized, highly accurate medical report the exact moment the surgery ends.
Okay, that is incredible power. We used to call computers calculators, but now we really have to look at them as inspiration machines.
Exactly.
But we also have to talk about where this token predicting system completely breaks down. Because an inspiration machine sounds great for brainstorming or drafting a quick email.
Sure.
But relying on an inspiration machine for a medical report or a legal brief feels incredibly dangerous. Like, I've personally seen these models confidently invent a completely fake historical fact, complete with dates and fabricated quotes.
Oh, definitely. That phenomenon is known as hallucination, and it is the direct, unavoidable result of how the architecture is designed in the first place.
Because it's just guessing.
Right. A GPT model has no grounded understanding of truth or facts or external reality. It does not possess a separate, verified database of true things that it goes and checks before it speaks.
It's just doing the math on the tokens.
Yeah, exactly. If the mathematical probability says that a certain fake name logically flows from a certain historical event, based on the statistical distribution of words in its training data, it just prints it.
So it doesn't know it's lying.
No. It is optimizing its output for fluency, grammar, and plausibility, not factual accuracy.
Okay, think about that one highly articulate person at a dinner party. You know the type.
Oh, we all know the type.
Right. They have a beautiful speaking voice, perfect pacing, and absolute confidence. But when they start talking about a topic they don't actually know much about, they don't stop talking.
They just pick it.
They just start fabricating stories, dropping fake names, weaving these elaborate narratives just to keep the conversation flowing smoothly. They sound incredibly authoritative, but it's entirely made up.
The model is that exact person at the dinner party.
Wow.
Just because it outputs flawless grammar and absolute logical confidence doesn't mean a single word of it is tethered to reality. If your prompt forces the model into a corner where the most statistically plausible next word forms a lie, it will lie without hesitation.
Man, that is a massive warning sign for anyone using these tools for critical work.
It really is.
Which actually brings us to the practical application for you, the listener.
Mhm.
If you are trying to survive this technological shift, or maybe you're looking to pivot your career into AI, you might hear terms like mask attention, decoder, or 175 billion parameters, and just feel completely unqualified to participate.
Totally overwhelmed.
So what is the actual practical takeaway for someone navigating this space right now?
The biggest takeaway is that you do not need a PhD in computer science to leverage this technology powerfully.
That's a relief.
Right. You just need to understand the fundamental mechanic we've discussed today. At its core, this technology is simply a probability model resting on three pillars: massive data, an attention mechanism, and a decoder architecture.
It's an engine that finishes your thoughts based on the context you provide.
Exactly. And because the model is entirely dependent on the context it is fed, because it can only look left to guess what comes next. The most valuable human skill isn't understanding the deep calculus of the parameters.
Right, you don't need to do the math yourself.
No. The most valuable skill is mastering prompt design, or what some call context engineering.
Okay, so you control the AI by controlling the context.
Precisely. If you give the model a vague one-sentence prompt, its attention mechanism has very little to anchor to. It will just resort to the broadest, most statistically average parameters.
Giving you a super generic, unhelpful response.
Exactly. But if you engineer the context, if you provide precise instructions, boundary constraints, tone requirements, and maybe a few examples of what good output looks like, you are essentially building a highly specific runway.
You're manipulating the probability engine.
Yes. You constrain it so that the only logical high-probability tokens it can generate are the exact, highly valuable specific work you need.
That makes total sense.
Generative AI is not the final destination of artificial intelligence. It is not AGI, artificial general intelligence. It is the absolute pinnacle of statistics.
It is not thinking about you.
No, it is actively rewriting the world, token by token. Understanding that distinction separates the people who will be replaced by the tool from the people who will wield the tool to actually thrive.
It is such a profound shift in perspective. There's a brilliant concluding thought drawn from our sources today that just perfectly sums up this entire dynamic.
Let's hear it.
Humans use thought to create language. GPT uses language to imitate thought.
Wow. That distinction is the key to absolutely everything we've talked about.
It really is.
And it perfectly sets up the massive problem the industry is trying to solve right now.
Right, because if this guessing machine is prone to hallucinations because it lacks a factual database, how do we actually fix it?
Well, I don't want to give it all away, but in our next deep dive, question 4, part 9, we are going to tackle RAG systems.
Retrieval augmented generation.
Yes, we will explore how engineers are figuring out how to attach a grounded factual knowledge base to this guessing machine to basically cure its hallucinations.
It completely changes its utility. We will see how combining the old filing cabinet retrieval systems with this new generative engine creates something entirely different. A true, personal, digital clone.
It's going to be a great discussion.
Thank you so much for joining us on this deep dive. Make sure you subscribe so you don't miss our exploration of RG systems.
We'll see you next time.
Chits. Oh, and I want to leave you with one final idea to mull over as you close this out and go about your day.
Oh, a provocative thought.
Exactly. Think about this. If GPT is simply predicting the next most probable word based entirely on the massive history of human text scraped from the internet, are its hallucinations really machine errors? Or are they just a perfect unfiltered mirror of our own human biases, our own fiction, our own contradictions?